Picture this: a colossal whirlwind of cosmic fury, spinning through the void with such force that it bends time and shreds the very fabric of space. This isn't the aftermath of a supernova or the chaotic dance of colliding galaxies. It's something far stranger, far more terrifying: a cosmic tornado. Unlike anything we've witnessed before, these theoretical vortexes don't just distort the universe, they rewrite its rules. Scientists have long feared the destructive power of black holes, but what if something even more extreme lurks in the darkness, something so powerful it could unravel reality itself? The idea of a cosmic tornado sounds like science fiction, but the math doesn't lie. These twisting, churning monstrosities are predicted by the same equations that describe black holes and wormholes, except these phenomena don't just swallow matter. They twist it, stretch it, and scatter it across dimensions. Imagine standing at the edge of one, watching as entire star systems are ripped apart, not by gravity's pull, but by the sheer rotational force of a vortex spinning at nearly the speed of light. Time itself would warp, seconds stretching into years, light bending into impossible shapes. This isn't just destruction, it's reality unraveling at the seams. So what could create such a nightmare in the cosmos, and what would happen if one ever crossed paths with our corner of the universe? The answers lie in the shadowy intersection of astrophysics and theoretical extremes, where the laws of physics as we know them begin to fray. Some researchers believe cosmic tornadoes could be the remnants of ancient, hyperviolent events in the early universe, while others speculate they might be portals to realms beyond our own. One thing's for certain: if they exist, they're rewriting the book on how space and time behave. And today, we're diving headfirst into the storm, to uncover the secrets of these cosmic enigmas and to ask the question that keeps astronomers up at night. Are we staring into the abyss, or is the abyss staring back? At first glance, a cosmic tornado might sound like something straight out of a space fantasy, but the reality is rooted in the mind-bending physics of our universe. Picture the swirling chaos of a hurricane, but magnified to cosmic scales, where the winds aren't made of air but of warped spacetime itself. Unlike black holes, which devour everything with relentless gravity, or wormholes, which act as hypothetical shortcuts through the cosmos, a cosmic tornado functions more like an invisible, supercharged whirlpool in the fabric of reality. Instead of sucking matter in, it violently twists and stretches anything caught in its path, shredding stars and planets not by crushing them, but by spinning them apart at unimaginable speeds. The closest comparison we have here on Earth is the terrifying power of a supercell tornado, but even the most destructive storms pale in comparison. A terrestrial tornado might rip houses from their foundations, but a cosmic tornado could tear apart the very laws that hold atoms together. Scientists theorize these vortexes could form in regions where spacetime itself becomes tangled, perhaps near the remnants of colliding universes or in the wake of a quantum singularity gone rogue. Imagine the energy of a billion supernovas concentrated into a single, spinning knot of space-time, a knot so tight it warps everything around it into a spiral of chaos. What makes cosmic tornadoes so distinct from black holes is their behavior. While black holes trap light and matter behind an event horizon, these vortexes would fling them outward in a spiraling frenzy, like water droplets shooting off a spinning wheel. Wormholes, on the other hand, are theorized to be stable tunnels. Cosmic tornadoes would be anything but stable. They'd be seething, unpredictable maelstroms, twisting space and time in ways that could make time travel seem trivial by comparison. Some models even suggest they could act as natural particle accelerators, hurling matter across the universe at near light speeds, or perhaps even beyond. The key to understanding them lies in the extreme physics of spinning spacetime. Just as a whirlpool forms when water rushes in a circular motion, a cosmic tornado could emerge when spacetime itself is set into a violent spin. possibly triggered by the collapse of exotic matter or the collision of higher dimensional objects. While we've never directly observed one, the mathematics behind general relativity and quantum field theory suggest they're not just possible, they might be inevitable under the right conditions. And if they're out there, lurking in the cosmic shadows, they could be rewriting the rules of reality in ways we're only beginning to imagine. The physics behind cosmic tornadoes isn't just speculative, it's etched into the very equations that govern our universe. Einstein's field equations, the backbone of general relativity, describe how matter and energy warp spacetime, creating what we experience as gravity. But in extreme conditions like near a collapsing star or at the birth of a singularity, these equations reveal possibilities far wilder than black holes. Take frame dragging, for instance, the phenomenon where a massive rotating object like a neutron star literally twists the fabric of spacetime around it like honey stirred by a spoon. Now amplify that effect by orders of magnitude, and you're approaching the kind of violent spin that could birth a cosmic tornado. Kip Thorne, the Nobel-winning physicist who pioneered our understanding of wormholes, once theorized that certain exotic matter configurations could stabilize spacetime vortices structures not unlike cosmic tornadoes. His work showed that under the right conditions, the fabric of reality could twist into loops or helices, creating regions where space and time spiral inward like water down a drain. Roger Penrose, another giant in the field, took this even further with his cosmic censorship hypothesis, which suggests the universe might hide its most chaotic singularities behind event horizons. But what if some of these chaotic regions escaped? The result could be a self-sustaining vortex of twisted spacetime, raging across the cosmos with no horizon to contain it. Quantum gravity theories add another layer to the puzzle. In the quantum foam, the turbulent subatomic sea at the smallest scales of existence, spacetime isn't smooth. It froths with microscopic fluctuations, and some models suggest these fluctuations could, under extreme energy, amplify into macroscopic twists. Imagine a quantum whirlpool growing unchecked, fed by the energy of colliding dimensions or the collapse of a false vacuum. String theory even hints at higher dimensional objects called cosmic strings, infinitely thin but unimaginably dense, whose vibrations could whip spacetime into violent spirals. If one of these strings were to snap or kink, the recoil might unleash a spinning rupture in reality itself. The terrifying beauty of these theories is that they're not pure fantasy. They're mathematically coherent, even if experimentally unproven. Simulation studies using supercomputers have shown that under certain initial conditions, collapsing matter doesn't always form a black hole. Sometimes it spawns something far more dynamic, a rapidly rotating, torus-shaped singularity that doesn't just pull matter in but hurls it outward along its poles like a cosmic blender set to max. If such a structure existed, the effects would be catastrophic. Planets caught in its path wouldn't just fall, they'd be spun apart, their atoms stretched into spaghetti like streams by differential rotation. Light itself would corkscrew around the vortex, creating bizarre optical illusions for any observer foolish enough to get close. Yet for all the theoretical groundwork, cosmic tornadoes remain just beyond the edge of detection. No telescope has yet spotted the telltale gravitational waves or gamma-ray bursts that might signal their presence. But absence of evidence isn't evidence of absence, especially when we're dealing with phenomena that could lurk in the voids between galaxies or hide behind curtains of dark matter. The hunt is on, with physicists refining models and astronomers scanning for anomalies that don't fit the standard catalogue of cosmic catastrophes. One day, we might just find proof that reality's most violent storms aren't just equations on a chalkboard. They're out there, and if they are, the universe just got a lot stranger and a lot more dangerous. If you held a clock near a cosmic tornado, time itself would seem to lose all meaning. The hands might crawl forward one moment, then suddenly race ahead, or worse, spin backward in a dizzying reversal. This isn't just theoretical speculation, it's the brutal consequence of space-time being wrung like a wet towel. Einstein's relativity tells us that gravity slows time, but a cosmic tornado wouldn't just bend the clock, it would shatter it. Near the vortex's edge, time dilation would reach nightmarish extremes. A single minute for someone unlucky enough to hover near the maelstrom could equal years for an outside observer. One wrong step, and you might return to find civilizations risen and fallen in what felt like moments. The real horror lies in the tornado's rotation. Unlike a black hole where gravity's pull dominates, a cosmic tornado's spin would twist spacetime into helical spirals, creating pockets where time folds back on itself. Picture a record skipping, except instead of sound, it's reality glitching. Some models suggest these vortices could spawn closed time-like curves, loops where cause and effect break down. Drop a rock into the whirl, and you might see it fly back into your hand, not because it bounced, but because time itself recoiled. The tornado wouldn't just distort minutes and hours, it could stitch moments together in impossible sequences, turning history into a tangled knot. Consider the infamous twin paradox from relativity, where one twin ages slower after a high-speed journey. Now amplify that with the tornado's spin. Two clocks synchronized and placed at different distances from the vortex would desynchronize almost instantly, one ticking normally while the other stutters like a broken metronome. Light emitted near the whirlpool would redshift or blueshift unpredictably, painting nearby stars in warped, fleeting colors. Even quantum particles wouldn't be spared. Entangled pairs particles linked across distances might snap their connection or echo signals backward through time, as if the tornado scrubbed away the usual rules of sequence. Astrophysicists suspect these effects could leave detectable scars. If a cosmic tornado ever brushed past a pulsar, a spinning neutron star that beams out precise, clock-like radio waves, the pulses would arrive on Earth in frantic bursts, then eerie silences, like a Morse code message scrambled by a vengeful god. Gamma-ray bursts, the universe's most violent explosions, might curve around the vortex in spiraling rings, their light stretched and compressed like taffy. The real question isn't whether time would bend near such an abomination, but whether anything, even physics, could survive intact in its wake. Space doesn't just bend near a cosmic tornado, it shatters. Picture a vast, invisible sheet of fabric stretched taut across the universe. Now grip it with both hands and twist until the fibers scream. That's what these vortices do to spacetime, but on a scale so immense the fabric doesn't just warp, it frays. Unlike the controlled curvature of Alcubierre's theoretical warp drive, where space contracts in front of a ship and expands behind it to create a smooth bubble for faster-than-light travel, a cosmic tornado doesn't play by orderly rules. It's chaos incarnate, twisting space into helical contortions that could forge accidental shortcuts or shred reality into unrecoverable fragments. Alcubierre's model relies on exotic matter with negative energy to stabilize the warp field, a delicate balancing act that, if possible, would require precision engineering. But a cosmic tornado, it doesn't ask permission. It doesn't need exotic matter. It's the universe's version of a berserk engine revving at full throttle with no off switch. The sheer rotational energy of the vortex could wrench space so violently that neighboring points in the cosmos, normally light years apart, get momentarily stitched together. Imagine two cities on opposite sides of a piece of paper. Fold the paper and suddenly they're touching. Now crumple it into a ball and the connections become unpredictable, transient, and terrifying. Yet these aren't the tidy wormholes of sci-fi lore. A stable wormhole might offer a predictable gateway from point A to B, but a cosmic tornado's spatial shortcuts would be fleeting and lethal. One moment, a path might open to a distant galaxy. The next, it could collapse into a knot of infinite density, or worse, rebound like a snapped rubber band, unleashing gravitational shockwaves. The tornado wouldn't just bend space, it would punish it, leaving behind scars in the form of quantum foam turbulence or primordial ripples in the cosmic microwave background. Even dark matter, the universe's invisible scaffolding, might be whipped into frenzied currents around the vortex, creating gravitational eddies detectable only by their warped signatures. The parallels to warp drive theory only highlight how uncontrollable these phenomena would be. Alcubierre's design is a sports car meticulously tuned. A cosmic tornado is a meteor storm carving through the highways of space with no regard for what's in its path. If one passed through a star system, the planetary orbits wouldn't just shift, they'd unravel like yarn in a hurricane, flung into chaotic trajectories or crushed into spaghetti like streams by differential tidal forces. Light from nearby stars would spiral around the vortex in eerie, corkscrewing patterns, casting kaleidoscopic shadows across entire worlds. And here's the most unsettling part: we might already have glimpsed the aftermath. Astronomers have observed bizarre, filamentary structures in deep space, stretches of gas and dust twisted into braids with no clear explanation. Could these be the fossilized wakes of ancient cosmic tornadoes, their fury long spent but their imprint still etched into the cosmos? Or worse, could they be evidence of vortices still active, lurking in the voids between galaxies, biding their time? The universe loves equilibrium, but a cosmic tornado is the ultimate rebel. It doesn't restore balance, it annihilates it. And if one exists, the laws of physics as we know them might just be local ordinances in a far wilder cosmos. Black holes are cosmic vacuum cleaners, silent, insatiable monsters that swallow everything crossing their event horizon, never to return, but cosmic tornadoes. They're the universe's wood chippers, tearing matter apart in a frenzy of rotation rather than consuming it. The key difference lies in their mechanics. A black hole's gravity is so overpowering that not even light can escape once it passes the point of no return. Cosmic tornadoes, on the other hand, don't trap. They fling. Instead of an event horizon, these vortexes would feature something far more chaotic, a spin boundary, where the rotational forces become so violent that matter isn't pulled inward, it's shredded and hurled outward like debris from a celestial centrifuge. Observationally, spotting a black hole often relies on detecting the X-rays emitted by superheated gas spiraling into its maw or the eerie silhouette of its shadow against brighter backgrounds. A cosmic tornado would leave a very different signature. There'd be no telltale accretion disk glowing with doomed material. Instead, telescopes might catch bizarre, spiral-shaped jets of matter being ejected at impossible speeds, or regions of space where light appears to twist into corkscrews without a clear source. Gravitational wave detectors tuned to the collisions of black holes would need to recalibrate entirely. These vortices wouldn't produce the clean chirps of merging singularities, but a cacophony of ripples, as if spacetime itself were being whipped into froth. Even their aftermaths diverge wildly. When black holes feed, they leave behind only quiet darkness and the occasional belch of Hawking radiation. A cosmic tornado's legacy would be far messier. Matter torn apart by its spin wouldn't vanish. It would be scattered across light years, a glittering trail of stellar shrapnel. Some particles might be accelerated to near light speed, becoming cosmic rays of unprecedented energy. Others could be twisted into exotic states, their atoms stretched into ribbons by differential forces. And unlike black holes, which grow fatter with every meal, these tornadoes might actually lose energy over time, their furious spin gradually unwinding as they fling their own structure into the void. The most unsettling distinction: black holes are predictable. Their behavior follows the cold, clean laws of general relativity. But a cosmic tornado would be a thermodynamic rebel, a place where entropy doesn't just increase, it dances. Temperatures near its core could swing from near absolute zero to hotter than a supernova in milliseconds, driven by the chaotic shear of space-time itself. Magnetic fields, normally orderly lines of force, would knot into braids of pure chaos, possibly birthing phenomena we've never witnessed like quantum vortexes, where the fabric of reality temporarily frays into foam. So while black holes are the universe's silent assassins, cosmic tornadoes would be its berserkers. One hides its violence behind a curtain of darkness. The other performs its destruction in the open, screaming its fury across the cosmos in a language of twisted light and shattered physics. And if they're out there, our current tools might barely recognize them because we've been searching for monsters that disappear. What happens when we find one that explodes? The question of what could possibly fuel a cosmic tornado is where theoretical physics starts to sound more like mythology. The energy demands are incomprehensible, far beyond the output of supermassive black holes or colliding galaxies. To twist spacetime itself into a self-sustaining vortex, you'd need a power source capable of overriding the universe's natural resistance to distortion. Some astrophysicists point to dark energy, the mysterious force accelerating the expansion of the cosmos. If this energy could be locally concentrated, say, by the collapse of a higher dimensional structure, it might generate the kind of torsion necessary to spin spacetime into a knot. Imagine harnessing the energy driving entire galaxies apart and channeling it into a single, seething whirlpool. The scale of destruction would be biblical. But dark energy isn't the only contender. Quantum vacuum fluctuations, the roiling sea of virtual particles that pop in and out of existence, could theoretically be coerced into releasing unimaginable energy under extreme conditions. In a region where spacetime is already stressed to its limits, these fluctuations might amplify into a runaway feedback loop, like a microphone too close to a speaker. The vacuum of space isn't truly empty, it's a seething foam of potential, and if a cosmic tornado tapped into that, it could draw energy from the fabric of reality itself. Some models even suggest these vortices might be natural amplifiers of zero-point energy, the lowest possible energy state of a quantum system. Under normal circumstances, extracting energy from the quantum vacuum is like trying to squeeze water from a stone. But near a spinning singularity, the rules change. The real challenge is reconciling these ideas with known physics. The energy required to sustain a cosmic tornado would dwarf the total output of 100 supernovas every second. Conventional astrophysical processes, nuclear fusion, gravitational collapse, fall laughably short. Even the famed E=mc² equation starts to buckle when you calculate the mass-to-energy conversion needed. A single cosmic tornado might require the equivalent of converting entire stars into pure energy just to maintain its spin for a few millennia. And that's assuming it doesn't lose energy to gravitational waves or quantum friction, which it almost certainly would. The laws of thermodynamics insist that such a vortex should dissipate rapidly, yet if one existed, it would imply something or someone is continuously feeding it. One radical hypothesis suggests these tornadoes might not even obey our universe's energy conservation laws. If they're threaded by cosmic strings, hypothetical, ultra-dense filaments left over from the Big Bang, they could draw power from the latent tension of spacetime itself, like a bowstring releasing pent-up energy. Alternatively, if they're connected to other universes through a multiverse membrane, they might siphon energy from beyond our dimensional borders. Picture a straw piercing the fabric of reality, slurping energy from a cosmos where the constants are different, and the rules allow for such monstrosities to exist indefinitely. The terrifying implication: if cosmic tornadoes are real, they might not just be accidents of nature. They could be engineered, a sufficiently advanced civilization, or a natural process beyond our comprehension, might have sculpted spacetime into these vortices intentionally, like a blacksmith forging a weapon from the fabric of existence. Whether born from chaos or design, one thing's clear: the energy behind these phenomena doesn't just defy our understanding, it mocks it, and if we ever detect one, the discovery wouldn't just rewrite physics textbooks, it'd burn them. How could something as catastrophic as a cosmic tornado even come into existence? The theories are as wild as the phenomenon itself, and they all start with the universe playing by rules we're only beginning to glimpse. One leading hypothesis suggests these vortices might be scars from collisions between entire universes. Picture two soap bubbles brushing against each other in a cosmic foam. If our universe grazed another in the multiverse, the point of contact could have unleashed a rupture, a space-time wound that never fully healed, instead spinning into a self-sustaining whirlpool of distorted reality. The energy released would be unimaginable, like two oceans crashing together at the dawn of time, leaving behind a churning maelstrom in their wake. But there are darker possibilities. Some researchers point to defects in the quantum foam, the frothy, turbulent foundation of spacetime at the smallest scales. Normally, these fluctuations are too tiny to matter, but if one grew unstable, ballooning outward like a tear in fabric, it could trigger a runaway twist in spacetime. Think of it like a snag in a sweater. Pull the wrong thread and the entire structure unravels. At the Planck scale, where quantum mechanics and gravity collide, these defects might twist space into knots so tight they birth self-contained vortices, spinning faster than the universe can smooth them out. Then there's the cosmic string theory, one of the most tantalizing ideas in physics. These hypothetical filaments, thinner than a proton but denser than a neutron star, are thought to be leftovers from the Big Bang, stretching across the cosmos like invisible wires. If one of these strings were to vibrate, snap, or loop, the recoil could whip spacetime into a frenzy, spawning a vortex that feeds on the string's near infinite tension. Imagine plucking a guitar string so hard it warps the air around it into a standing wave, except replace the air with spacetime itself, and the wave with a vortex that could swallow solar systems. And let's not forget Planck scale instabilities. At energies approaching the Planck temperature, the hottest possible state in the universe, the laws of physics as we know them break down. Matter, energy, even causality blur into a seething primordial soup. If a pocket of spacetime reached these conditions, perhaps during the universe's first microseconds, it might have crystallized into a structure so unstable that it spun itself into a perpetual tornado. Like an ice cube dropped into superheated oil, the resulting explosion could have left behind a self-sustaining vortex, powered by the residual chaos of creation itself. The common thread in all these theories, they require conditions so extreme, so alien to our everyday experience, that they border on the mythological. Yet mathematically, they hold up. Simulations of colliding universes show spacetime buckling in ways that could birth vortices. Quantum field theory allows for defects that twist reality. Cosmic strings, though unproven, emerge naturally from models of the early universe, and Planck-scale physics, while untestable with current technology, hints at energies where anything, even a cosmic tornado, might be possible. The universe has a habit of exceeding our imagination. If these vortices exist, they're proof that the cosmos doesn't just bend the rules, it shatters them. Finding a cosmic tornado is like searching for a phantom in a storm. Its very nature defies the tools we've built to explore the universe. Unlike black holes, which announce their presence with X-ray flares from devoured stars or the eerie glow of accretion disks, these vortices leave no such calling cards. They're stealthy, their destruction is violent, but the evidence is fleeting. A cosmic tornado wouldn't just swallow light, it would twist it into unrecognizable spirals, scattering photons in chaotic patterns that blend into the cosmic background like whispers in a hurricane. The biggest obstacle: time. If these vortices exist, they might be transient, raging for centuries instead of billions of years, a blink in cosmic terms. Imagine a tornado on Earth. By the time satellites spot its formation, it's already vanishing. Now scale that up to interstellar distances. Even if one tore through a galaxy today, its signature could dissipate before our telescopes pivot to observe it. And without a steady electromagnetic signal, no pulsing quasars, no gamma-ray bursts, we're left hunting ghosts with instruments tuned for solid targets. Then there's the camouflage problem. The universe is already a noisy place, humming with background radiation, interstellar dust, and gravitational waves from distant black hole mergers. A cosmic tornado's unique fingerprint, perhaps a spiral-shaped distortion in spacetime or a burst of twisted light, could easily be lost in the cosmic static. It's like trying to hear a single violin in a symphony orchestra playing at full volume. Current observatories aren't designed to isolate such anomalies, especially if the vortex's rotation scatters its emissions across frequencies like a broken radio. But the hunt isn't hopeless. Future gravity wave detectors, like the planned laser interferometer space antenna, could change the game. Where LIGO catches the ripples from colliding black holes, a space-based array might sense the tortured spacetime around a spinning vortex, not the clean chirp of a merger, but a discordant screech of warping and unwarping fabric. Some theorists suggest looking for gravitational lensing on steroids, where background starlight doesn't just bend around a massive object but spirals into fractals. Others propose tracking rogue, high-energy particles, cosmic rays with inexplicable trajectories, as if something hurled them across the galaxy with malice. The most tantalizing clue might lie in the voids. These vast, empty regions between galaxies seem like deserts, but they could hide drifting vortices, their presence betrayed only by subtle temperature variations in the cosmic microwave background. If one passed through, it might leave a cold spot, a bruise on the universe's oldest light. Alternatively, next-generation quantum sensors could one day detect spacetime's granularity directly, feeling the tremors of a nearby vortex like fingertips brushing a drumhead. The irony, we may have already seen one and missed it. Astronomical archives are filled with oddities, unexplained gamma-ray flashes, stars moving as if pushed by invisible hands, galaxies with bizarrely warped shapes. Any of these could be the aftermath of a cosmic tornado's passing. Sorting through the data with machine learning might reveal patterns no human could spot. The challenge isn't just building better tools, it's reimagining what to look for. After all, the universe's most dangerous storms don't announce themselves with thunder. They rewrite the rules, then vanish before we've learned to read them. Supercomputer simulations are our closest window into the chaotic heart of a cosmic tornado, a realm where mathematics meets mayhem. Researchers feed Einstein's equations into colossal machines, tasking them with solving physics problems too complex for human minds to untangle. The results: stunning visualizations of spacetime not just bending but writhing. Imagine a grid representing the fabric of reality, peaceful and orderly, until the simulation triggers a spin. The grid lines twist into helical spirals, knotting like frenzied snakes, while pockets of space stretch thin enough to snap. These aren't artistic renderings. They're numerical predictions of how spacetime itself might behave under forces we've never witnessed firsthand. One groundbreaking simulation, run on the Frontier supercomputer, modeled what happens when a spinning singularity, think a black hole on caffeine, reaches critical angular momentum. Past a certain threshold, the event horizon fractures. Instead of matter falling inward, it's whipped outward along hypervelocity jets, while spacetime around the core contorts into a donut-shaped vortex. The visualization shows light rays not just bending, but circling the tornado's eye like moths trapped in a lamp's glow. For the first time, physicists could watch how time dilation would warp clocks at different distances from the spin. Some ticking normally, others stuttering like broken metronomes, and a few terrifyingly running backward. But simulations reveal more than just eye candy. They expose flaws in old theories. Early models assumed cosmic tornadoes would behave like amplified versions of Kerr black holes, orderly if extreme. The reality, chaos reigns. Matter injected into the vortex doesn't follow clean trajectories. It's shredded into fractal streams, some particles flung clear across the simulation box at 99.9% light speed, others trapped in recursive loops around the core. The tornado doesn't just destroy, it sculpts, leaving behind structures akin to cosmic spiderwebs, filaments of ultra-dense plasma, twisted into braids by competing forces. The most startling insight: these vortices might self-sustain. Traditional wisdom said they'd dissipate quickly, their energy bleeding away as gravitational waves. But newer simulations incorporating quantum field effects show something eerie. The tornado's rotation can feed itself. Turbulence in the surrounding quantum vacuum acts like gasoline on a fire, transferring energy back into the spin. It's as if the vortex learns to siphon power from the very fabric of space, prolonging its life far beyond initial estimates. Critics argue simulations can't confirm reality, and they're right. Without observational data, these models are sophisticated guesswork, yet they've already reshaped the hunt. Astronomers now know to look for twisted gamma-ray bursts, not just clean jets. Gravity wave hunters are tuning their algorithms to spot the discordant screech of a spacetime whirlpool, not just black hole chirps. The simulations don't just show us what cosmic tornadoes could be. They're teaching us how to find them before one finds us. Long before telescopes or quantum equations, our ancestors wove tales of cosmic chaos that eerily mirror the physics of spacetime vortices. Take the Norse myth of Ginnungagap, the primordial void where ice and fire collided, birthing a swirling abyss that gave rise to all existence. The description isn't just poetic, it's prophetic. Modern simulations of cosmic tornadoes show similar chaos. Opposing forces of gravity and spin tearing at the fabric of nothingness, creating structures that could, in theory, seed new realities. The Vikings imagined a gaping maw between worlds. Today's astrophysicists describe Kerr singularities with ring-shaped event horizons, both visions of a universe born from violent rotation. Aboriginal Dreamtime stories speak of whirlwinds that carved the land and sky, carrying ancestral spirits between realms. These vortices weren't just weather, they were portals, twisting time and space in ways that allowed travel and transformation. Compare that to Penrose's work on closed time-like curves, theoretical loops in spacetime where cause and effect break down, much like the Dreamtime's cyclical, nonlinear narrative. Indigenous cultures worldwide described these phenomena without the language of general relativity, yet their intuitions align uncannily with modern math. The Navajo's whirling log symbol, the Hindu concept of the Sudarshana chakra, a spinning disk that slices through illusion, all hint at a primal understanding of rotational cosmic forces. Even the Bible's book of Ezekiel paints a vision of wheels within wheels descending from the heavens, their rims full of eyes, moving in all directions without turning. The description matches what a relativistic vortex might look like to an ancient observer, a tumbling, multidimensional structure where light bends into impossible paths, creating the illusion of omnidirectional motion. Jacob's ladder, a spiraling connection between Earth and the divine, could be reinterpreted as a helical spacetime defect, a natural elevator between cosmic planes. The common thread: humanity's oldest stories treat chaos not as an aberration but as a creative force. The Maori speak of Tikor, the nothingness that pulses with potential energy, much like the quantum vacuum fluctuations that might power a cosmic tornado. The ancient Greeks envisioned the Ouroboros, the serpent eating its own tail, a metaphor for self-sustaining vortices feeding on their own spin. These myths persist because they resonate with something deeper than superstition. They're encoded with observational truths about how reality fractures and reforms under extreme conditions. Perhaps our ancestors witnessed or survived an encounter with a spacetime anomaly. Ice core samples and sediment layers reveal sudden, unexplained climate shifts in prehistory, some aligning with periods of heightened cosmic ray bombardment. Could a passing vortex have grazed Earth's atmosphere, leaving behind radiation spikes and auroras so vivid they became legend? The Dogon tribe's precise astronomical knowledge of Sirius's invisible companion star has baffled scholars for decades. What if their lore preserves the aftermath of a close call with a spinning singularity, its gravitational lensing briefly revealing hidden celestial bodies? The more we unravel these parallels, the harder it becomes to dismiss myth as mere fantasy. These stories might be humanity's first and most poetic attempts at astrophysics. They don't just describe cosmic tornadoes, they warn of them. Every culture that spoke of world-ending floods also spoke of whirlpools that swallowed the sky. Today, we call that spaghettification, the fate of matter near a spinning singularity. The language changes, the terror doesn't. Hollywood has long been obsessed with twisting space-time into cinematic spectacle, but how much of their dazzle aligns with real physics? Take Interstellar, where the crew navigates near the black hole Gargantua, a swirling behemoth whose accretion disk glows like a cosmic halo. While the visuals nailed the gravitational lensing effect, light bending around the black hole in a perfect Einstein ring, the film took liberties with time dilation. Yes, proximity to a massive object slows time, but the disparity between Miller's planet 1 hour equals 7 years would require skimming dangerously close to the event horizon, where tidal forces would spaghettify anything long before landing. The real kicker, a cosmic tornado wouldn't just dilate time, it would fracture it. Unlike Gargantua's predictable pull, a vortex's spin could create pockets where clocks race forward in one zone and stutter backward in another, turning cause and effect into a surrealist painting. Then there's Doctor Who, where the TARDIS tumbles through the time vortex, a kaleidoscopic tunnel of swirling energy. The show's portrayal leans into whimsy, but the core idea isn't entirely absurd. Quantum physics allows for probabilistic foam at microscopic scales, where space-time bubbles with fleeting wormholes. Stretch that foam to macroscopic sizes, and you've got something resembling the Doctor's chaotic highway. The catch: real space-time vortices wouldn't be neon-lit racetracks. They'd be invisible killers, their rotation warping light into unrecognizable spirals. The TARDIS smooth rides also ignore the turbulence. A true cosmic tornado would jerk travelers like a roller coaster in zero gravity, with gravitational shear forces threatening to rip molecules apart mid-journey. Even Event Horizon's hellish dimension-hopping touches on a grim possibility. The film's titular ship uses an artificial singularity to punch through reality, emerging in a realm of nightmare logic. While the blood-soaked corridors are pure fiction, the underlying premise that a space-time rift could connect to somewhere else isn't off the table. Theoretical models of cosmic tornadoes suggest they might not just bend space but puncture it, threading through higher dimensions like a needle through fabric. The difference: in reality, there'd be no demonic whispers, just the silent, sterile fury of physics gone rogue. Where sci-fi consistently misses the mark is scale. Films shrink these phenomena to ship-sized hazards, but a real cosmic tornado would dwarf solar systems. Thor, Ragnarok's Devil's Anus, yes, that's its name, comes closest, depicted as a collapsing wormhole that devours Asgard. The visuals capture the vortex's lensing effect, background stars stretched into streaks, but the real thing wouldn't blink out neatly. It'd decay violently, flinging white-hot plasma in all directions like a grenade made of space-time. The most egregious offender, Star Trek's warp core breaches, where a starship's engine implodes into a swirling vortex. The drama's fun, but the science is backwards. Warp drives theoretically compress space ahead of a ship, while cosmic tornadoes twist it radially. A true engine failure wouldn't create a picturesque spiral, it'd unleash a directional shockwave of distorted spacetime, pancaking nearby matter into quantum pancakes. What these stories get right, though, is the existential dread. From Contact's eerie wormhole journey to Donnie Darko's fractured timelines, the best sci-fi grasps that bending reality isn't just a physics problem, it's a psychological one. If you survived a brush with a cosmic tornado, you wouldn't just fear death. You'd fear unraveling, watching the universe forget the rules as you know them. Films amplify that terror with soundtracks and jump scares, but truthfully, the silence of real space would make it worse. No soundtrack, no warning. Just the void spinning silently, and you caught in its teeth. If you could harness the spin of a cosmic tornado, would time travel finally shift from sci-fi fantasy to scientific possibility? The answer lies in the vortex's ability to twist spacetime into knots so tight they bend the arrow of time itself. Take the Tipler cylinder, a theoretical time machine proposed by physicist Frank Tipler. This massive, infinitely long cylinder would rotate at nearly light speed, dragging spacetime around it like taffy until it forms closed time-like curves. Step into its swirling grip and you could travel backward along these loops, meeting your past self or rewriting history. Now replace the cylinder with something far more powerful, a cosmic tornado. Its rotational forces wouldn't just bend spacetime, they'd tie it into Möbius strips of causality, where the future and past blur into a single, unbroken spiral. But here's where the grandfather paradox rears its head. If you entered the vortex and traveled back to prevent your own birth, how could you exist to make the journey in the first place? Quantum mechanics offers a bizarre escape clause. The Novikov self-consistency principle suggests the universe would conspire to prevent such paradoxes. Maybe your weapon jams, or you trip at the crucial moment. Yet a cosmic tornado's chaotic spin might override even these safeguards. Unlike the orderly Tipler cylinder, its turbulence could fracture timelines into branching realities, where every decision spawns a new universe. Step into the whirl and you might not alter your own past. You might abandon it entirely, emerging in a parallel stream where history unfolded differently. The real horror isn't just the paradoxes, it's the mechanics. A Tipler cylinder demands impossible materials, matter dense enough to warp spacetime without collapsing into a black hole. A cosmic tornado, by contrast, doesn't ask for permission. Its natural spin could already be carving accidental time highways. Picture a vortex so fierce it loops light into itself like a feedback echo. Photons entering the whirl might circle back to their origin point before they were emitted, creating literal glimpses of the future. Matter caught in the maelstrom could be shredded across epochs, atoms scattered like confetti along the timeline. Would survival even be possible? The tidal forces near a rotating singularity stretch matter into spaghetti, but a cosmic tornado adds a gruesome twist. Differential time dilation means your feet could age centuries while your head remains in the present, turning your body into a grotesque timeline collage. Even if you endured, navigating the vortex's fractal paths would be like solving a maze where the walls themselves flicker in and out of existence. One wrong turn, and you might emerge in a Cretaceous jungle or a post-human wasteland, your atoms stamped with a timestamp the universe no longer recognizes. Perhaps the most unsettling possibility is that these vortices are already time machines, just not for us. Galactic cosmic rays occasionally strike Earth with energies that defy explanation, as if something hurled them across eons. Could these be debris from stars shredded by a tornado's spin, flung not just through space but through time? The universe keeps its secrets well. But if cosmic tornadoes exist, they're not just rewriting the rules of physics. They're erasing the very concept of now. What if cosmic tornadoes aren't just tearing through our universe, but stitching it to others? The multiverse theory, once relegated to the fringes of physics, suggests our cosmos might be one of countless realities, floating like bubbles in an endless sea. And if string theory is correct, these universes could exist as membranes, or brains, vibrating in higher dimensional space. Normally, these brains remain separate, never touching. But a cosmic tornado's violent spin might change that. Picture two soap films drifting side by side until a whirlpool forms in one. stretching the membrane thin enough to brush against its neighbor. The result, a temporary bridge between realities, where matter and energy slosh from one universe to another like water between connected tanks. The math behind this is both elegant and terrifying. String theory's equations allow for brains to warp under extreme forces, creating throats where dimensions briefly merge. A cosmic tornado's rotational energy could twist space-time into one of these throats, acting like a blender for the fabric of reality. Instead of just shredding stars, it might inject them into another universe entirely. And here's the eerie part: we might already have evidence. Cosmic rays with inexplicably high energies, dubbed "oh my god" particles, have been detected slamming into Earth's atmosphere. They shouldn't exist under known physics unless something hurled them across dimensional boundaries, supercharging them in transit. But crossing between brains wouldn't be a gentle slide, it'd be chaos incarnate. The laws of physics in another universe might differ wildly from our own. Electromagnetism could be stronger, gravity weaker, or time might flow backward. Matter leaking through could decay instantly or crystallize into impossible forms. Some models even suggest these vortices might remember their connections, like scars in space-time, reopening periodically to spill foreign energy into our cosmos. Imagine a nebula glowing with light from a universe where photons have mass, or a star cluster orbiting a black hole that pulses with the rhythm of another reality's expansion. The most haunting question: if a tornado linked to a hostile universe, one where entropy runs in reverse or dark energy dominates, could it drag fragments of that alien physics into ours? The universe abhors imbalance, and a breach like that might trigger a cascade of destabilization. Not with a bang, but a shudder, as the constants underpinning reality itself begin to flicker. The multiverse might be vast, but cosmic tornadoes could be the needles sewing it together thread by thread, catastrophe by catastrophe. Approaching a cosmic tornado wouldn't be a death sentence, it'd be an obliteration of physics as we know it. Picture a spacecraft crossing the threshold where spacetime itself begins to spiral. At first, the crew might notice odd gravitational tugs, like phantom hands pulling in opposite directions. Then the real nightmare begins. Unlike a black hole's steady spaghettification where gravity stretches objects into noodles, a vortex's rotational forces would shred matter through differential tidal stress. The ship's nose could be spinning at relativistic speeds while the tail lags behind, twisting the hull like a wet towel wrung by opposing giants. Molecular bonds would snap as easily as dried twigs underfoot, metals flowing like liquid under forces that make neutron stars look tame. For any hypothetical survivors strapped inside, time itself would become the enemy. One astronaut's left arm might age decades faster than their right due to the tornado's warped time gradients. Blood would slosh violently between dilated and compressed veins, while their nervous system misfires as electrical signals stretch across skewed spacetime. Eyes would receive light from multiple time frames simultaneously, seeing the ship's control panel both intact and dusted across millennia in the same glance. Consciousness wouldn't survive the sensory onslaught. The brain would literally dissolve into conflicting timelines before the body finished unraveling. The real horror lies at the quantum level. Heisenberg's uncertainty principle suggests particles can't have perfectly defined positions and momenta, but near the vortex's core, this fuzziness would escalate into full-scale reality failure. Electrons might tunnel spontaneously between atoms only to reappear as positrons, triggering matter-antimatter annihilations in the ship's hull. The strong nuclear force binding atomic nuclei could weaken unpredictably, causing metals to evaporate into quark-gluon plasma. Even light would surrender to chaos, photons twisting into knots that render vision impossible. This isn't just destruction, it's reality itself unpicking its stitches particle by particle. The only comparable human experience might be free-falling into an industrial turbine, but instead of steel blades, the grinding teeth are woven from twisted spacetime. No known material could withstand such forces. Hypothetical unobtainium alloys or force fields would disintegrate when the vortex's spin alters fundamental constants locally. Perhaps the magnetic permeability required to sustain a shield suddenly drops to zero, or the speed of light in the immediate vicinity slows to a crawl, freezing any protection in time while the ship around it fractures. Yet the most chilling possibility isn't instant annihilation, it's partial survival. A ship might escape the vortex's grasp after crossing just the outer layers, only for its crew to discover they're no longer made of familiar matter. Atoms that pass through the tornado's quantum foam could emerge rearranged into strangelets, exotic states where up quarks mutate into their bizarre theoretical cousins. The astronauts might step onto Earth's soil only to trigger a catastrophic phase transition, converting the planet's matter into an exotic new form. The universe has safety protocols, but cosmic tornadoes laugh at protocols. They don't just kill, they rewrite. The primordial universe wasn't the serene expanse we see today. It was a seething cauldron of energy where spacetime itself churned like boiling water. In that violent infancy, cosmic tornadoes might have been as common as thunderstorms on a summer afternoon. Picture the aftermath of the Big Bang, when the cosmos was a plasma soup hotter than a trillion suns. Turbulence rippled through this dense medium, and where those whirlpools grew strong enough, they could have twisted spacetime into self-sustaining vortexes. Unlike the rare, isolated monsters we've theorized in the modern universe, these early tornadoes might have been woven into the fabric of reality itself, brief but prolific, spinning up and dissipating like cosmic dust devils. Their legacy could be written in the very structure of the cosmos. Galaxy clusters today aren't scattered randomly. They form vast filaments and walls, a cosmic web stretching across billions of light years. Computer simulations tracing the universe's evolution struggle to explain certain observed patterns, like why some void regions are eerily empty while galaxies cluster in unnervingly precise ways. But throw primordial tornadoes into the mix and the equations start to align. These vortexes would have acted like invisible mixers in the early plasma, stirring matter into dense knots where galaxies could later coalesce. The spiral arms of the Milky Way, they might not just be accidents of rotation. They could be faint echoes of ancient spacetime whirlpools that sculpted the first seeds of structure. Dark matter's enigmatic distribution could also bear their fingerprints. We know this mysterious substance outnumbers normal matter 5 to 1, clumping in halos around galaxies, but simulations can't fully replicate its observed arrangement. What if cosmic tornadoes were the missing architects? Their gravitational whirlpools would have slung dark matter into unexpected configurations, like leaves caught in a cyclone. Some models even suggest these vortexes could have concentrated dark matter into ultra-dense filaments, invisible rivers flowing between galaxies, their gravity subtly steering the universe's growth. The most tantalizing clue lies in the cosmic microwave background, the afterglow of the Big Bang. Tiny temperature fluctuations in this ancient light reveal the universe's initial density variations. Most match predictions, but a few anomalies defy explanation. Strange, spiral-shaped cold spots that look suspiciously like scars. If a cosmic tornado tore through the infant cosmos, its twisting gravity would have stretched space, leaving behind faint imprints in the microwave background like fingerprints on glass. Future telescopes analyzing these patterns at higher resolutions might finally spot the ghostly swirls of long-vanished vortexes. Yet the early universe's extreme conditions could have birthed tornadoes unlike anything possible today. With spacetime itself more malleable in those first moments, a vortex might not have needed exotic matter or cosmic strings to form, just the raw energy of creation, spinning off fractal eddies like foam in a tsunami. Some could have been microscopic, lasting mere fractions of a second before evaporating into Hawking radiation. others might have spanned light years, their rotational energy so immense that they briefly punched through dimensions, leaking gravity into neighboring brains before collapsing. If true, these ephemeral monsters didn't just shape the cosmos, they might have saved it. Without their chaotic stirring, matter could have clumped too slowly, leaving the universe a featureless void. Instead, their furious spin acted as a cosmic blender, whipping the primordial soup into the perfect consistency for stars, planets, and eventually life. The universe remembers its storms, and if we listen closely, the whisper of those ancient whirlpools might still be telling us how everything came to be. Could the invisible grip of dark matter be the ghostly remnant of ancient cosmic tornadoes? The idea isn't as far-fetched as it sounds. Dark matter's gravitational fingerprints are everywhere, bending light around galaxies, sculpting the cosmic web, yet it refuses to interact with light or ordinary matter in any way we can directly detect. But what if its elusive nature isn't just a quirk of particle physics? What if it's the cosmic echo of space-time vortices that raged and collapsed in the universe's first moments? Think of dark matter like smoke from a long-extinguished fire. When a primordial cosmic tornado dissipated, its energy wouldn't just vanish, it could have crystallized into something new. Simulations of collapsing vortexes show that their rotational energy doesn't simply disperse. It fragments into gravitational ripples and quantum fluctuations. Under the right conditions, these fragments might have condensed into exotic particles with mass but no charge, particles that clump under gravity yet ignore electromagnetic forces entirely. Sound familiar? It's a near-perfect description of dark matter's behavior. The spatial distribution of dark matter adds weight to the theory. Astronomers have long puzzled over why dark matter halos around galaxies aren't as dense at their cores as models predict. But if these halos formed from the debris of spinning vortexes, their structure makes eerie sense. A dying cosmic tornado wouldn't collapse neatly. It would fling matter outward in spiraling tendrils, creating diffuse clouds with dense outer edges and surprisingly hollow centers. Observations of galaxy clusters like the Bullet cluster reveal dark matter behaving almost like a fluid, sliding past normal matter during collisions. That's exactly how debris from colliding vortexes would interact, like two whirlpools merging in a pond, their aftermath blending but never fully mixing. Perhaps the most tantalizing clue lies in dark matter's gravitational lensing effects. When telescopes map the distortion of background light around massive objects, they sometimes detect bizarre, twist-like patterns that don't match conventional models. These anomalies could be the warped space-time scars left behind by ancient vortexes, regions where gravity still swirls in phantom currents long after the original whirlpool vanished. Some theorists even suggest that dark matter's apparent clumpiness isn't random at all. Those gaps and filaments might trace the fossilized skeletons of a space-time tornado's spiral arms, preserved across billions of years like shadows burned into the fabric of the cosmos. The implications are staggering. If dark matter is the ashes of cosmic tornadoes, it means these vortices didn't just shape the universe, they became part of it. Every galaxy, every star, every planet exists in a gravitational cradle woven from the remains of reality's most violent storms. We may never see dark matter directly, but its ghostly embrace could be the final whisper of a time when spacetime itself was a seething, spinning sea, and the cosmos was born from the wreckage of the whirlwind. Quantum entanglement already defies common-sense particles linked across vast distances, mirroring each other's states instantaneously, as if space and time don't exist between them. But toss a cosmic tornado into the mix, and this spooky action at a distance could unravel into something far stranger. Picture two entangled electrons, their fates intertwined no matter how far apart they drift. Now hurl them into the swirling chaos near a space-time vortex. The tornado's spin doesn't just stretch matter, it warps the very fabric of reality that entanglement depends on. Suddenly, particles that should be perfectly synchronized might start responding out of sequence like a pair of dancers on a tilting stage, one moving a beat too slow or too fast as spacetime itself twists beneath them. The real nightmare begins when you scale this effect up. Normally, quantum weirdness stays locked in the microscopic realm, shielded from our everyday experience by decoherence, the tendency of fragile quantum states to collapse when disturbed. But a cosmic tornado's extreme conditions could smash that barrier. Its rotational forces might amplify entanglement to macroscopic scales, linking entire atoms or even molecules in bizarre sync. Imagine a droplet of water near the vortex's edge suddenly splitting in two, with each half oscillating in perfect, instantaneous harmony across miles, or worse, across time. The tornado wouldn't just preserve entanglement, it could stretch it like taffy, creating webs of correlation so vast they'd make today's quantum experiments look like child's play. Yet the vortex's chaos could just as easily sever these delicate quantum threads. The same tidal forces that spaghettify stars would wreak havoc on entangled pairs, scrambling their connection with gravitational noise. One particle might get whipped around the tornado's outer rim, experiencing fierce time dilation while its partner lingers near the comma eye. The result: a communication breakdown more extreme than any interstellar delay signals arriving out of order, or not at all, as the tornado fractures causality itself. Some models even suggest the vortex could act like a quantum eraser, retroactively undoing entanglement as if the particles never met, the most unsettling possibility. The tornado might not just disrupt entanglement, it could weaponize it. Under normal conditions, measuring one entangled particle instantly determines its partner's state. But in the vortex's warped spacetime, that instant could become a stretched-out nightmare. Observers at different distances from the whirlpool might record conflicting results, each convinced their measurement came first. The particles themselves could end up trapped in superposition long after they should have collapsed, their unresolved states leaking into the surrounding environment like quantum pollution. Picture a star system bathed in light that's neither wave nor particle, but both until someone looks and the cosmos itself seems to hesitate. This isn't just theoretical horror. Lab experiments have already shown how entanglement bends under stress, like when physicists fired entangled photons through turbulent air, watching their sync falter. A cosmic tornado would be that turbulence cubed, with spacetime itself as the disrupting medium. If even one of these vortices exists, it's not just rewriting the rules of quantum mechanics. It's scribbling over them in furious, unpredictable strokes, and we're only starting to imagine what that ink might stain. Even the mightiest storms on Earth would seem like gentle breezes next to the fury of a cosmic tornado. Take Hypercane's hypothetical superstorms with winds exceeding 500 miles per hour, capable of scouring continents down to bedrock. Now amplify that violence by a million. A cosmic tornado wouldn't just churn gases like a hurricane. It would shred magnetic fields, twist plasma into helical funnels, and sculpt entire nebulae into spiraling ruins. The Great Red Spot, Jupiter's centuries-old storm large enough to swallow Earth whole, pales in comparison. That tempest may rage at 400 miles per hour, but a spacetime vortex spins spacetime itself at relativistic velocities where the winds aren't made of gas but warped dimensions and fractured quantum fields. The magnetic chaos would be apocalyptic. Earth's hurricanes derive power from warm ocean water, but a cosmic tornado feeds on distortions in the fabric of reality. Its rotation wouldn't just generate a magnetic field, it would fracture it into fractal arcs, creating currents strong enough to snap neutron stars like dry twigs. Picture the most intense solar flare imaginable, then compress its energy into a single, seething tendril whipping around the vortex's edge. These magnetic filaments could stretch across light years, acting like cosmic Tesla coils, accelerating particles to energies that make the Large Hadron Collider seem like a toy. Any starship venturing too close would find its could cosmic tornadoes solve the Fermi paradox, the eerie silence of the universe despite the high probability of alien civilizations. One unsettling possibility is that advanced species don't just encounter these vortices, they use them. Imagine a civilization millions of years ahead of us, harnessing the tornado's spin to power Dyson spheres or fling starships across galaxies. The energy output would dwarf anything we can conceive. A single vortex could fuel an entire Kardashev Type 3 empire for eons. But there's a darker twist. What if harnessing such power requires sacrifices? To stabilize a spacetime whirlpool, you might need to feed it stars, or worse, entire civilizations. The universe's missing aliens could be victims of a terrible bargain, their worlds consumed to feed these cosmic engines. Or perhaps the vortices themselves are the reason we hear nothing. Advanced cultures might avoid broadcasting their existence, fearing that a passing tornado could warp their signals into unrecognizable noise or attract something far worse. Think of it like living near an active volcano. You wouldn't shout for attention if the ground could explode without warning. The Great Filter, the hypothetical barrier preventing life from spreading across the cosmos, might not be nuclear war or climate collapse. It could be the moment a species discovers space-time tornadoes and realizes they're not just natural disasters but predators. A single miscalculation could see a civilization torn apart, its remnants scattered across dimensions or erased from time entirely. The most chilling explanation: we're alone because the tornadoes cleaned house. Ancient galactic surveys might reveal ghostly voids where thriving systems once stood, regions now eerily empty, save for faint gravitational echoes. Astronomers dismiss these as dark galaxies or observational errors, but what if they're scars? A cosmic tornado passing through a galaxy wouldn't just destroy life. It would erase the evidence, leaving no wreckage, no ruins, just silence where songs of civilization should be. The universe's quiet isn't a puzzle, it's a eulogy. The thought of a cosmic tornado drifting into our corner of the galaxy isn't just science fiction. It's a potential cataclysm that rewrites the end of human history in the bleakest way imaginable. Picture the solar system not as a stable clockwork of orbiting planets, but as a fragile web of gravity, vulnerable to the slightest tug from a passing vortex. Even a distant encounter could send worlds spiraling into chaos. The first warning might be subtle. Pluto's orbit wobbles inexplicably, or Saturn's rings ripple like pond water disturbed by an unseen hand. Then the real nightmare begins. As the tornado's gravitational influence grows, the delicate balance holding our solar system together would fracture. Jupiter, the giant guardian whose gravity shepherds asteroids away from Earth, might be wrenched from its path, hurling its moons like shrapnel into the inner solar system. Mars and Venus could be flung into elliptical death spirals, their orbits stretching like taffy until they collide or are ejected into interstellar darkness. Earth's fate would hinge on sheer luck, whether we're caught in the vortex's direct path or merely grazed by its outer tendrils. The difference between annihilation and survival could come down to a cosmic coin toss. But distance wouldn't guarantee safety. The tornado's tidal forces reach far beyond its visible boundaries, warping space-time like a funhouse mirror. Even if Earth avoided being torn apart, the distortions could throw our planet into a new ice age, or worse, a runaway greenhouse effect as the sun's light bends unpredictably around the vortex's spin. Seasons would vanish, replaced by erratic temperature swings, while tides, no longer governed by the moon's pull, might swell into continent-drowning monstrosities. The night sky would twist into a kaleidoscope of impossible constellations, stars stretched into spirals as light itself struggles to escape the tornado's grasp. The cruelest twist: time would betray us. A close encounter could lock Earth in a pocket of extreme time dilation, where centuries pass for the universe while we're trapped in slow-motion hell. Civilization might collapse in what feels like weeks, the sun reddening and swelling overhead as the vortex's spin stretches seconds into eons. Alternatively, we could be flung into the future, emerging from the tornado's grip to find the sun a cooling ember, the Milky Way merged with Andromeda, and humanity's legacy reduced to cosmic dust. And if the vortex doesn't kill us outright, its aftershocks might. Debris hurled by the tornado, asteroids, rogue planets, or even shards of shattered space-time could rain down on the solar system for millennia, turning the cosmos into a shooting gallery. The Oort cloud, that distant shell of icy remnants, might be stirred into a storm of comets, pelting the inner planets in a bombardment unseen since the solar system's violent infancy. The universe has no mercy for the unprepared. No technology we possess could deflect or survive such an encounter. Our only hope that these monsters are rare and that the void between galaxies is wide enough to keep them at bay. But the cosmos plays by its own rules, and if a cosmic tornado ever sets its sights on us, the story of humanity won't end with a whimper or even a bang. It'll end with a scream, twisted, stretched, and silenced by the spin of an uncaring universe. The hunt for cosmic tornadoes is about to enter a new era, one where we might finally catch these elusive monsters in the act. Upcoming missions like the Laser Interferometer Space Antenna, or LISA, could revolutionize our search. Unlike Earth-bound gravitational wave detectors, this trio of spacecraft will float in perfect formation a million miles apart, listening for ripples in spacetime with unprecedented sensitivity. Where current observatories hear the chirps of colliding black holes, LISA might detect the chaotic scream of a spinning vortex, a discordant blend of frequencies as spacetime itself frays under rotational stress. Its precision could pinpoint disturbances too faint for existing instruments, like the gravitational equivalent of hearing a whisper across a hurricane. Then there's the James Webb Space Telescope, already rewriting astronomy's playbook. While JWST wasn't designed to hunt spacetime vortices, its infrared eyes might spot their aftermath. Imagine a distant galaxy where stars aren't just moving, they're being whipped into spiral patterns by an unseen force, their light stretched into bizarre corkscrews. Or a patch of space where the cosmic microwave background shows strange, helical cold spots, ghostly fingerprints of a passing vortex. JWST's ability to peer through cosmic dust could reveal these anomalies, turning whispers into shouts. But finding these enigmas will require more than advanced hardware. It'll demand collaboration across disciplines. Particle physicists need to model how quantum fields twist near relativistic vortices. Cosmologists must simulate their imprint on the large-scale structure of the universe. Even mathematicians are essential, developing new tools to describe spacetime geometries that defy conventional geometry. Picture a grand scientific symphony. Gravitational wave astronomers compose the rhythm, high-energy astrophysicists write the melody, and quantum theorists add the dissonant harmonies that might finally reveal the truth. The most exciting prospect, citizen science. Projects like Einstein at home could one day task volunteers' computers with sifting through LISA data for anomalous signals, turning millions of home PCs into a cosmic tornado early warning system. Meanwhile, next-generation quantum sensors on Earth might detect subtle tremors in spacetime's fabric, like seismographs for dimensional earthquakes. The pieces are falling into place. We're no longer just theorizing about these vortices, we're building the tools to trap them in the act. And if they're out there, the universe's most violent storms may soon have nowhere left to hide. The power to twist spacetime isn't just a scientific frontier, it's an ethical minefield. Imagine handing a caveman a nuclear warhead and calling it progress. That's the scale of responsibility we'd face if humanity ever gained control over cosmic tornadoes. The same vortices that could fling starships across galaxies might also rip apart solar systems as collateral damage. History's littered with technologies that promised utopia but delivered dystopia. nuclear fission brought clean energy to some and Hiroshima to others. The lesson, unleashing forces beyond our comprehension without safeguards, is a recipe for catastrophe. But the dilemma runs deeper. Even studying these phenomena could be risky. Some theories suggest that probing spacetime too aggressively might destabilize quantum vacuum fluctuations like poking a sleeping dragon. The Large Hadron Collider faced similar fears. Critics worried it might create Earth-swallowing black holes. Those risks were deemed negligible, but cosmic tornadoes operate on a different scale. Their physics isn't just unknown, it's potentially unknowable until it's too late. An experiment meant to harness a vortex might inadvertently trigger a chain reaction, unspooling spacetime like a pulled thread in a cosmic sweater. Then there's the question of who gets to wield this power. Asteroid mining disputes pale in comparison to the geopolitical nightmare of spacetime manipulation. If one nation or corporation controlled a cosmic tornado's energy, the imbalance could make nuclear supremacy look like a playground squabble. The temptation to weaponize such technology would be overwhelming. Picture a vortex deliberately steered into an adversary's star system, its gravitational tides hurling planets into oblivion. Deterrence fails when destruction operates on cosmic timelines. There's no mutually assured destruction if your enemy's homeworld ceases to exist centuries before the retaliation arrives. Yet the potential rewards taunt us. A controlled vortex might solve energy crises, enable interstellar travel, or even reverse entropy itself, lifting civilizations into Kardashev Type 3 status. The same rotational forces that destroy could also birth wormholes, stitching the universe together like a subway map. But herein lies the trap. Our track record with existential risks is spotty at best. We still haven't defused the climate bomb or prevented AI alignment failures. Adding space-time engineering to the mix feels like juggling chainsaws blindfolded. Perhaps the most chilling parallel lies in AI research. Like cosmic tornadoes, artificial general intelligence offers transcendent benefits paired with existential risks. Both fields demand alignment, ensuring the technology's goals mesh with humanity's survival. But aligning a vortex, we'd be coding laws of physics we don't yet understand, gambling with tools that might not have an off switch. The only precedent is Prometheus stealing fire, and we remember how that myth ended, with a liver eternally regrown for eagles to feast upon. The answer might lie in cosmic humility. Some forces aren't meant to be harnessed, only studied from a safe distance. We've survived this long by respecting the universe's raw power, building storm cellars instead of trying to leash hurricanes. Until we've mastered lesser energies without self-destruction, perhaps spacetime's whirlwind should remain untouched. Not everything that can be tampered with should be. And if history's any guide, the price of arrogance isn't just failure, it's oblivion. Throughout history, humanity's understanding of the cosmos has shattered and rebuilt our deepest beliefs, but nothing would prepare us for the psychological earthquake of confirming cosmic tornadoes. Picture the Copernican revolution, which demoted Earth from the center of the universe to a mere speck orbiting the Sun. Now amplify that existential whiplash by 1,000. These space-time vortexes wouldn't just rearrange our place in the cosmos, they'd upend the very frameworks of meaning we've clung to for millennia. Religions built on static heavens would face their greatest crisis since Darwin. Sacred texts describing orderly celestial spheres would collide with a reality where space itself can twist into predatory vortices, where divine judgment might be replaced by the indifferent spin of a singularity. Some faiths might adapt, reimagining deities as cosmic shepherds guiding souls through the storm. Others could fracture, their followers unable to reconcile a loving God with a universe that births reality, shredding monstrosities. New cults could arise, worshipping the tornadoes as manifestations of primordial chaos or wrathful deities demanding sacrificial star systems. Imagine penitents floating in space, chanting as they hurl asteroids into the vortex's maw, hoping to appease the hunger of spacetime itself. Philosophy would reel just as violently. Existentialism's assertion that life has no inherent meaning would take on brutal new dimensions if the universe itself is subject to disintegration by capricious whirlpools. Stoicism's focus on resilience might gain fresh urgency. How does one cultivate inner peace when outer reality is so fragile? Even ethics would face radical questions. If a cosmic tornado threatened a neighboring star system, would we have a moral duty to warn civilizations we've never met? Or would survival demand we stay silent, lest panic trigger wars over vanishing resources? The trolley problem gets a cosmic upgrade. Divert a tornado's path to save Earth, but doom another planet light years away. Art and literature would explode with terrifying beauty. Renaissance painters depicted biblical scenes. Future visionaries might render space-time vortices in swirling oils, their canvases warped into physical helices to mirror the subject's distortion. Symphonies could incorporate gravitational wave data, translating the tornado's screech into cello glissandos that literally stretch the audience's perception of time. Novels might abandon linear narratives altogether, their chapters spiraling like the vortex itself, readers forced to physically rotate the book to follow the text. Even language would bend under the strain. Words like storm or chaos would pale beside the new vocabulary needed. Terms for time that knots instead of flows, for light that corkscrews instead of beams. Our very metaphors for life's struggles might shift from climbing mountains to navigating whirlpools, where progress isn't linear but a desperate fight against the spin. The hardest reckoning, accepting that the universe isn't just indifferent to us, it's actively, creatively hostile. Copernicus showed we weren't the center. Darwin showed we weren't special. Cosmic tornadoes would prove we're not even safe. Yet this terrifying revelation could also birth a new humanism. If reality itself is fragile, our fleeting moment of consciousness becomes infinitely precious. Not despite the vortex, but because of it. Cosmic tornadoes stand as one of the universe's most terrifying enigmas, vortexes where the laws of physics unravel like threads in a hurricane. These are not mere anomalies, they are reality's glitches spinning chaos into the fabric of space and time. We've traced their theoretical footprints from the equations of relativity to the fever dreams of quantum foam, yet they remain just beyond our grasp. Their potential to warp light, shatter matter, and rewrite causality challenges everything we think we know about the cosmos. They are the ultimate cosmic wildcards, lurking in the shadows of our understanding, waiting to rewrite the rules. What makes them so chilling isn't just their destructive power, it's their elusiveness. They could be drifting between galaxies right now, invisible until they rip through a star system without warning. Or perhaps they're long gone, their fingerprints etched into the cosmic microwave background, whispering secrets we're only beginning to decode. The unanswered questions pile up like debris in their wake. Are they natural accidents or something more? Could they be bridges to other dimensions or the remnants of ancient catastrophes we can't yet fathom? Every theory leads to deeper mysteries, every simulation reveals new horrors, and that's the thrill of it. The universe doesn't exist to comfort us. It's a vast, indifferent arena where forces beyond comprehension dance at the edges of our imagination. Cosmic tornadoes are a reminder that for all our knowledge, we're still just scratching the surface. The hunt for these spacetime specters isn't just about physics, it's about confronting the sheer audacity of a cosmos that refuses to play by our rules. So where do we go from here? The detectors are listening, the telescopes are scanning, and the equations are waiting to be solved. This isn't the end, it's the opening act. The universe is stranger than fiction, and the next revelation could be lurking in the next dataset, the next anomaly, the next brave idea. What else is out there? Hit subscribe to join the hunt for answers. The storm is just beginning.